All right, let's just start with the basics. Name, rank, unit. You know how to drill. Just give us an introduction to yourself and then we'll go into the company.
Hi, Amir. Thank you very much for having me. My name is Moshiel. I'm the CEO and co-founder of Addionics. Background is material science, mostly semiconductor. More than a decade ago, I moved to the battery space. I gained a PhD at Imperial College London in the field of batteries, and this is how I entered into the battery world.
That's right. And we met about a decade ago. You were describing to me then, right? It was like in 2014, 2015, you're describing to me this PhD that you were doing about trying to extend battery life, make batteries more efficient, make them run longer. And I remember nodding very politely and thinking to myself, this guy's really smart. Try and just, stay with him to see how this develops. And lo and behold, 10 years later, you're the CEO and founder of Addionics, which is a battery tech company. Tell us just a little bit about the company, how many people, where you situated, funding and products and all that.
Sure. We are 90 employees, mostly based in Tel Aviv in Israel, but we have also a team in California, in Europe, in the UK. We raised more than $80 million. Very good mix between strategic investors and financial investors. We have strategic investors like General Motors and Scania from Volkswagen Group, Every Denison, Novelis, Jack Nippon, Magna.
Moshiel, can you just tell me what is the difference between a strategic investor and a financial investor? You've mentioned a couple of auto companies now.
Yes.
So just tell us, what is a strategic investor?
Yeah, so strategic investor, that is by the name, that's the definition of the investor. They are not looking for only financial returns. They are looking also for strategic value. Either it's going to improve their product, they are going to use the product, they are going to be customers later on, or going to use it in some form that it's going to bring them some strategic advantage and some competitive edge, which is different from financial investors that are not looking to be a customer or to use the product by themselves, only looking to the increase of the shares and to make sure that the return is going to be higher than their initial investment.
Great. Remember, this is the de-jargonizer. We have to do these things. Okay, let's go back to the company. It's 90 people, 90?
Yeah.
You've raised $80 million, some from strategic investors like car makers, and then also from financial investors. Can you just take us back to the core idea behind your work and the company?
We are developing a smart 3D porous current collector. A current collector is a component in every battery. You have current collector on the anode side. It's a copper foil. And you have current collector on the cathode side. It's aluminum foil. Today, this foil is a 2D and dense. And be surprised, but the component hasn't changed. The architecture of this component hasn't changed since the invention of the lithium-ion battery. Even Tesla using the same component they developed back then in the 90s. The concept is not new to move to smart 3D porous material. Even before lithium-ion batteries, there were technologies like nickel metal hydride. They used some porous metals. With the move to lithium-ion batteries, which enable a revolution of being mobile, we have our mobile phone, laptops, electric vehicles. One of the goals was to commoditize batteries, to build millions of batteries a day at competitive cost. And with any alternatives to the dumb 2D metal foil, it wasn't, I would say, applicable or attractive enough to change that foil. The foil is good enough and there is no any reason to change. And all the alternatives were off the shelf and not designed for batteries.
Can I just pause you there? Can we take it up a few levels? You're talking about cathodes and lithium-ion batteries, and there was a lot of technical stuff in it. Can we just take it up 100,000 meters? And I'm looking down at how things are powered, batteries, right? Battery technology has been around, how long? 100 years, 80 years, 70 years?
Few hundred years.
Few hundred years, batteries. These things power everything now that's mobile, and not just mobile, right? I mean, you have also electricity and power. I mean, everything that's not plugged into an electrical outlet needs a battery. So a car, electric bike, I guess, ships, planes, everything. Those batteries have been made in the same way using the same technology, which is lithium-ion battery technology. And this is fine. This is great. Our world runs on this, but it could be a lot more efficient. And this is our core idea, is to change the world by enhancing battery technology. And then we'll go down into the technical stuff.
So first, maybe if you want me to explain what is a battery. So battery is a closed system that you don't need to opposite to engine. You don't need to fuel that system. The amount of energy that's storing the system is limited. It's fixed. And it's a rechargeable process. You can charge and then recharge the battery or operate your device once your battery, and you can refill it with electrons. But it's a closed system. It's not like an engine that you need to fuel it with gas or oil or other type of fuels. Electrons move very fast, so it's very effective and efficient system. And in terms of the efficiency of the system, it's very close to a perfect scenario. In real engine, you have lots of losses, and in batteries, you have less losses. There is no any mechanics that involve in the process. So you have ions that move from one side, one electrode, to another electrode. There is positive and negative. There is a diffusion, so it's a spontaneous reaction, moving from one side to another side. Once they move to another side during the discharge, for instance, they are releasing electrons. And these electrons, we can use them to operate a device. And the other way, we are pumping to the other side ions that actually bringing electrons in to the system so they can store more energy. And that's a rechargeable process going back and forth like a musical chair.
Is that, just as a quick example, let's say an ambulance. So the ambulance has an engine, but it also needs batteries inside where there's like a mobile ICU. There's all sorts of, of medical devices, the heart thing, right? So you also have an engine, you also have a battery, and the battery stuff is a closed system.
Conventional vehicles with internal combustion engine, the batteries that are coupled with the engine are startup battery, to start the car and also to operate some of the electricity, not only in the ambulance, but we also need to have air condition and other type of electric elements that require the electricity. The engine can generate electricity, but you need a battery to apply the current. In most of the vehicles, so traditionally, the use of this type of battery, it's a lead acid battery. It's less expensive battery. It's very old tech. You don't need to have high energy battery because you have the energy from the engine, from the gasoline. So you don't need that. But if you have electric engine, you need then electric batteries because you cannot run electric engines from using lead acid battery. You need high energy battery. You need to store high energy. You need to operate this battery for long cycles. So it's a reversible process, and you need to drive your car for longer range and to charge it fast because people used to fuel their cars. So the concept is if you can recharge your vehicle at the same time that you charge your car, or the same time you actually fuel with gas. So this need to be like around 5-10 minutes. If you make it like few hours, it's not pleasant.
You mentioned combustible engines and electric engines. And now I guess we're at a time in history where we're slowly or fast moving from combustible engines to electric engines, but mostly in cars and in some areas, right? There's still a lot of places that are coming online just with combustion. So when you get, investments from strategic investors, from big companies who might also be customers, what do they look for you to help them with to become more of an electric car company or to get their batteries? Like, what is the reason that, they're coming to you instead of doing this in-house or at another company?
Most of the innovation in the battery space is through the chemistry of the battery. And the lithium-ion batteries is a technology that for you to stay, it's not going to leave anytime soon. All the alternatives are not good enough to compete with lithium-ion battery. So most of the effort is how to improve the existing technologies or how to make the lithium-ion batteries with higher energy that's going to last longer and you can charge them faster. And most of the focus was through the chemistry. And we propose a new approach to do it through the physics, through the architecture. And we took a component that was overlooked, like most 99% of all the batteries in the world produced with the same component that hasn't changed. It's 2D metal foil. You have copper on the anode side and aluminum on the cathode side. It hasn't changed. And we focus only on that component. We are the only company in the world that doing both. Usually the current collector produced by legacy metal companies, either doing aluminum foil or copper foil. There is no any combination, but we are looking at that problem from very holistic, I would say, a view that at the end of the day, the battery is a closed system. If we are making the electrode with the porous 3D electrodes, you're going to enhance the performance, reduce cost, and that's the holy grail. Everyone wants a cheaper battery that's going to give you better performance. So that's exactly what we're doing. We're improving the lifetime. We're reducing the trade-off between power to energy, and I will explain what is trade-off. Today, either you are building high energy batteries or high power batteries. You cannot get both.
Can you give me an example of high energy, high power?
Yeah, for instance, you're using power tool. You need high power. You don't need that this is going to give you pulses to drill for minutes. You need those pulses for tenths of seconds. It's enough, but you need very high power in order to penetrate the wall, for instance. That need to last for 10 minutes.
Right.
You do it like for pulses. Whenever you need pulses, so you need high power. Whenever you need to use the application for longer time, you need high energy. Most of the vehicles, they don't require high power. Most of the vehicles. Of course, if you're using Formula One, you want high power. But if you have a family car, most important is the range. Anyway, electric vehicles are very fast and the road is shorter in order to get acceleration that you need to get high power. So the road is like too short to get that type of power.
You have to charge all the iPads and phones at the back also.
Yeah, but fast charging is also associated with high power, high energy at like short time. And that's type of phenomena that required high power. And this is, of course, against the need of high energy. And we've managed to reduce that trade-off. And you can look at that as a slice of bread and you put peanut butter, and the peanut butter is the energy. And the bread is just a parasite. It's there, it's a substrate. It's not contributing to the energy. It's an inactive component. While we're making this bread porous, fluffy, like English muffin, so the peanut butter can get also inside. So we can put more peanut butter. We're increasing the energy. And at the same time, we have more contact with the metal. So we can actually have higher power.
I just want to try and understand. So if you have a pita with falafel and hummus and trina and all that stuff, and that stuff is porous, right? The trina starts to come out of the pita and land on your hand and on the floor. And so does the material, they're not holding it in, they start becoming porous. Doesn't that leak the battery? Doesn't that cause,
That was one of the biggest challenge to incorporate like porous 3D material in the battery manufacturing process, because you actually coat the active material on top of the foil. And if the foil is fully dense, you are not going to get any bleed through or leakage. In our case, we designed the structure in a way that will prevent any bleed through. So we have zero bleed through. That's part of our IP and some secret sources, how to create structures that prevent any bleed through. So you can use existing manufacturing process. That's one of the advantages of using our technology. You don't need to have new type of processes or new type of CapEx or equipment. It's a drop-in, completely drop-in. We're not changing.
To a car battery, for instance, you can you need to open it up, insert your thing, close it up again? How does that work?
So today, when you manufacture the battery, you have a big jumbo roll of a foil. You unroll the foil and then you coat the active material. You put the peanut butter on the foil. And then you need to dry it, to put it inside a big furnace. And then you're doing calendaring. It's like applying pressure to get the active material, the peanut butter, thinner, and to get better adhesion. So to increase the energy density.
Adhesion?
The bonding to the metal.
And is that where the name Addionics comes from?
No, actually Addionics is addition of ions, so more ions, additive deposition from ionic solution. The way that we produce our copper porous current collector, we're using electro deposition process. We are taking a well-known process, which using low-cost CapEx. And instead of producing from this process a commodity, because the copper foil is a commodity, and the 3D is very important for the fast charging, the high power, and the porosity is important for the high energy, because in the porous, we can put more material. And we have a very good flow of electrolyte through all the layers. So we're enhancing the flow of the electrolyte and reducing the resistance, and with better conductivity. And this is important to have more robust cells to last longer.
Yeah, I need to try and get my exploding head around this. There's a lot going on. On the very basic level, what I hear you saying is the way batteries have been made for decades. In a certain way, it's basically called the current collector, right? You have two poles, positive and a negative. There's copper. Electrons go from the one side to the other, and you either do high energy, which is like a pulse, like a drill, or, high energy. No, that's high power, and then high energy is longer lasting. And that's always been a trade-off. You've come along and you've said, we've found a way to bypass that trade-off, and then bordering all of that and keeping all of that inside the system is, I guess it's dense copper or, dense copper, and that keeps the system closed. Now, Addionics comes along and says that dense copper, if we put a layer of film on it, I think, or we put a layer.
So instead of the dense copper, we're replacing that with our porous 3D metal. And this is what our customers really like, so they can see us as a second source. Instead of the big roll of the down 2D metal foil that they're buying from legacy companies, they can use the same process with the same cell design, just replace one roll with our roll. We are producing that in a roll-to-roll format. And then we can adjust into their coating lines with the same specification.
I'm getting this. I'm really getting this. The copper that you're replacing with your own, what is it made of? Is that going too much into IP, or can you just basically say?
Well, it's the same composition of the foil today. We're trying to have minimum change, but maximum impact. So it's the same metal composition, exact same, with the same, I would say, purity, with the same conductivity, same mechanical properties. That's the idea, to have at least parity of all the performance, and only to change the architecture.
And once the architecture is changed, all those elements and all those electrons and all of that stuff that's, doing what it's doing inside the system can seep in a little bit more, a little bit longer. And that then gives you longer battery life, more efficient battery life, because it's able to do its thing longer.
Correct. So the battery is more robust, and that's a big surprise. It's an overlooked component. No one tried to replace that, or no one believed that there is a big impact of that component. Managed to reduce the internal resistance inside the battery, and then the battery is more effective. Lifetime longer. We have better heat dissipation, so we're generating less heat in the battery, which is important for the lifetime, and also able to do fast charging as well, which today, when you do fast charging, you generate lots of heat, lots of resistance. And if we are reducing that, so we allow us to do it in more extreme condition. We are in a very unique position that we are attractive to the whole supply chain. We have strategic investors from all levels of the supply chain, from the component manufacturers, from the machinery operators, from the tier one, from the end user as well, like the automakers, that most of them not building batteries by themselves, but they are the end user. And everyone wants to have some impact on the supply chain. Traditionally, the automotive OEM didn't build anything apart from the engine, but the battery is today engine. This is what gives you the performance. This is also associated with the cost. More than 40% of the cost of the car is the battery. So if you are a car maker, you don't want to lose all this power performance-wise, and also in terms of cost. You don't want to lose all of that to battery maker. Tesla changed all the concept, how to think about electric vehicles. They own all the data of the batteries. At the beginning of electrification, automotive players didn't understand that they need to own the data. That is important.
When you say owning the data, you mean the performance of the batteries over time, and what does that tell them? Distance.
Correct.
And, right.
You can update the profile of charging every time. You can look at that as a software, that you can update the software. You can see the state of the battery, state of charge. That's maybe more technical, but to understand what is the status of the battery. And then to change your protocols, how to charge it, for instance, in order to extend lifetime or to extend your range, and how to do it. So you can do it over the air. You can do it as a software. Like you can think about iPhone. And this is what the Chinese are trying to do. They're trying you to use electric vehicle like you're using your mobile phone, like a smartphone that you're replacing every few years, and you can get updates of the software. So similar way, you are going to move to the electric vehicles world.
We spoke about the technical stuff, the chemistry, the physics, and then, this whole new way that you're changing the current collector. And then we almost just jumped right into the business side and the industry side and the Chinese and all that. I want to just go back to that pivot point between the technology and the industry. You said that your batteries and the way they perform, has an impact. It reduces heat. It increases efficiency. Now, are you able to give an indication, like how much longer does the battery last or how much less heat? What is that percentage of improvement, I guess, per battery? And then I would like to kind of layer up. So let's say that then scales, right, to a lot of industries. What is then the impact on industry itself? A lot of these industries rely on batteries, right?
It really depends on the system, on the chemistry that we're using, but I can give you some examples that we did with customers. So we took existing chemistry with their cell design, and we've managed to extend the lifetime even up to like 100%. And this is like significant if you can double the lifetime, with conventional, I would say, architecture, you get 1,000 cycles. And with Addionics, you can get 2,000 cycles. This is significant.
In my laptop, for instance, the lifetime of the battery usually is, let's just say 1,000 cycles. It's probably more, right? Maybe 10,000.
It depends on the system, but in specific system, we can even double that. In some other system, we can increase it by 40, 50%.
Wow. So a really kind of game-changing increase. Like your devices can last longer, your cars can drive further, whatever it is that you're using battery for.
Especially if we're using extreme cases or high energy chemistry, the design for extreme cases. So in this type of chemistries, you have a big potential in terms of high energy, but then you have a trade-off.
Can you give me an example? Is that like a killer drone or something?
For instance, for drones or for hypercar, that you need to have fast charging and you need to have high energy as well. And then you have the trade-off, so very short cycle life in the battery. And then we can take this type of batteries and the improvement would be greater than the already optimized cells for long lifetime.
So it used to be either high energy, low time. Let's say a drone that does a lot of stuff can only be in the air a minimal amount of time versus, again, I made the mistake. High power is low time. High energy is longer time. Now you're saying you can have both.
Correct.
Wow.
We've managed to get much lower degradation, to get more capacity, to access more capacity at high power, and also to generate less temperature or less heat. And that's like exactly what we're saying about the trade-off between power to energy. We took high energy cells, we did fast charging. With the existing conventional cells, we managed to reduce the temperature by a few degrees, which also significant.
That's also for cooling, right? Because you need a lot of you need a lot of power for cooling.
Yeah. When I started the company, I said like everyone is trying to solve the problem from the system level. You are putting like a bandage on the issue and the problem, on the pain. And we said, why not to go deep and to solve it at the building blocks and the infrastructure inside, not on the system level. So you can put lots of cooling, lots of battery management system on the system level. But if you're going to solve it on the electrode level, so you will see you have less need of all this solution on the system level.
If we go back, you're basically saying that it depends on the deployment. You could, increase the battery's performance in both power and energy, reduce heat and charging time by, 100%, sometimes more, sometimes less. And so that can directly impact the business of your investors, of your clients. They can use this battery technology to cars that the batteries last longer, drive faster, all sorts of things. How much is that worth to them? Like, how big is this battery tech and battery innovation industry? Like really take it out into kind of a global level.
Like it's a huge market. Of course, the automotive market is one of the biggest, but you have batteries everywhere. You have energy storage, robots, AI, mobile devices, and so on. So the electrification revolution is happening. Yes, we were hoping that it will accelerate faster and we'll see more adoption, but still there is a growth. So it's a huge market. And we have our financial model that we believe what is our value that we can bring. And we're talking about around 10% per kilowatt hour. That's a value that Addionics can bring.
You can reduce the cost of the batteries by 10%, and we're talking billions, trillions of batteries around the world.
Correct. Of course, we have some blind spot that we don't know exactly. For instance, if you are extending the lifetime of the battery, what is the insurance policy that the automakers is paying to make sure that there is no explosion? And if we are going to reduce the chances for explosion, of course, it costs money, but it's not.
I'm not sure I understood. So there's a first order impact, which is extending battery life, making it cheaper, faster charging, use in, harsher conditions. And that brings down the cost, and that's already a huge thing. And then you're saying that could then have a second order impact on insurance, on
environment, insurance, brand. Every company that we are meeting, they want to use our technology. They see the results, they see the material. We are building our next generations of technologies before even launching our first generation. We're moving very fast. That's the privilege of being a startup, being able to move fast and always improve product. We understand that it will be very difficult. Our vision is to implement those structures in every battery in the world. Very difficult to do it alone and to do it fast. That's one of the reasons of bringing strategic from the supply chain. We can see them as a scale-up partner, and we negotiate with few also to do the scale-up. They have footprint all over the world. They're already familiar as supplier with the automakers. And once we are going to give them the license to produce it at scale all over the world, the penetration of Addionics will be easier because no one sees a startup as a tier one supplier. It's very difficult to do this jump from innovation, like a startup company, to being a supply company. And we don't have this experience of building facilities all around the world. So of course, no one is going to volunteer to do the first small plan instead of us. We did it. And now we're in the stage of finding the partners that will do the scale up. And in that way, we're reducing that mass production risk.
I heard you say you have product market fit, but is the greatest challenge then finding a product partner fit or like a company, an OEM to go out and scale this in their own?
We have our strategic investors that are already willing to be our scale-up partners. And we're finalizing now the agreements doing that. The plan is 2026, we're still going to produce it in-house with our capacity. We have 0.5 gigawatt hour capacity that we completed the build a few months back. We need also to scale up not only the capacity, but also the dimension of the product. We started with doing that in a desktop machine, and then moved to roll. And we managed to make the roll wider and wider.
What's roll to roll? Everyone says this roll to roll. Is that kind of just mass manufacturing or what is it?
Correct. If you want to do mass production, you produce it in a roll to roll. It means that you have lines that can produce theoretically endless.
Got it.
And that's where we get high throughput. And also it's very cost effective process. And, one of my former professor, PhD, she's Dean of Engineering at Imperial, told me that if you're not going to make batteries in a wall-to-wall format, probably it's not going to commercial. If you're using other technologies that not going to use, because at the end, batteries are commodity. And this is exactly what the Chinese are doing perfectly. High quality and mass production, and manage to reduce the cost of the battery. LFP, it's $35 per kilowatt hour. It's insane.
How much has that gone down from? 10 years?
10 years, $1,000 per kilowatt hour. So they managed to really make it cost effective and to reduce the cost dramatically. And it was against all the analysts that said, okay, it's going to be around $100 around this years. And we managed to get.
How are they doing that?
First, they are willing to lose money in order to take the market.
Subsidized industries.
Subsidize and killing competition by doing that. As I mentioned, even in the supply chain, copper foil, they're selling copper foil in raw material prices. So there is no any way for them to get any profits. And every Western company is that trying to compete. It's not a fair competition. They're losing, and more companies going to bankruptcy. For us, it's an opportunity because they understand they cannot compete with China with commodity. The only way to compete is with high value component, with technology, innovation. And this is exactly where we are bringing. And this is also create opportunities because we can use dead assets today that going to bankruptcy and retrofit. When I explain about our process, it's not completely different from the existing process of copper foil, but we are adding our technology on top of that to allow us to use the same low-cost capex that today in the West, it's like big elephant, dead assets that everyone trying to understand what to do. And we are like saving them in order to generate a competitive advantage, and they will be able to compete with the commodity market.
It's amazing to me how many Israeli startups I meet that have this kind of core ability in this time that we're at now to help the West compete with Asia. It's unbelievable, whether it's in chip design, battery tech, in all sorts of things. And it sounds like you're in that space. And I cut you off earlier, but you started saying, today our greatest challenge is. So let's talk about that for a few minutes.
Yeah, so we mentioned the scale up, and the goal is not to do it by ourselves. We are not alone, to do it with scale up partners, companies that already produce at scale. They have a worldwide footprint and already a supplier, or I would say approved and credible supplier to the end user. So that's one challenge. The second one is the pricing. That's another big challenge, especially the big companies, the big OEMs. They will try, and they're trying to squeeze us down. They have procurement team that all their job is to squeeze down their suppliers. And we need to justify our value. So we're doing that through tests, through building batteries together, showing them the value. And second thing, which is quite another like big challenge, today they are using this type of component, which is commodity. They are valued at pricing that per weight. And we're making like porous material. We can reduce the amount of copper up to 50%.
They charge for the battery per ton of copper.
Exactly. They buying the copper foil per weight, ton, kilogram. But we are making that for us. So it's like shooting our leg if we're going to use the same metric.
It's shooting more than your leg. It's shooting your hip.
We need to find a new metric. So we are converting that to kilowatt hour energy, the value. But at the end of the day, they also want to see a price with some other metrics. So we are going to show them per meter. So this is more acceptable metric that they can use.
Per meter of?
Square meter.
Square meter of just of space of their battery.
Yeah, or the roll that they are buying. Like you can either say it's weight like 1 ton, or the length is like 10 kilometers, for instance.
And so how does that benefit you? I mean, you're still making the same length.
We can compare it in a way that will be beneficial for us and not for them. If we are going to compare it by weight, it's going to be beneficial for them because we're not getting any cost on the value that we're bringing. By per meter, we can even say, you can take 10 meter, and this 10 meter, you can get more energy and compare it to 10 meter, conventional 10 meter, it will be more costly, 10% more costly, and you get less performance benefit.
If you can show them that you're reducing the cost of their overall product by 10%, then you can say to them, well, give me 2% of that, right? Is that not?
Exactly. So the idea is to get more than 2% and to increase our share in this split. But it depends, like on the contract, depends on clients.
We're heading towards the end, and I want to just ask you something. You mentioned a bit earlier that the electrification revolution is happening, but that you expected it to move faster. What do you mean by that?
Yes, so electrification, mainly in electric vehicles, the hope that we'll see more aggressive penetration of electric vehicles to the market. Maybe in Israel, we don't see that. We see many Chinese brands, but for instance, in the US, we don't have any Chinese brand. traditional automakers. They are building many type of models, but all their announcement of being completely zero emission and generate or producing only electric vehicles, they are postponing that. So if they say like 2030, now they push that. So they still understand. And I think that's what we see, that electric vehicles are expensive for them. They cannot really compete with China on the cost of the electric vehicles. And the profit, they're making profit mostly from the conventional internal combustion engine. And so they still want to be attractive to the shareholders. There is also the threat from Chinese, from BYD, from Tesla that are 100% electric. So they need to balance between the tension of making profit, like short term, and also think long term how to catch up with the leading companies in the world. Because eventually, I believe we'll see electrification, and when we'll have infrastructure, still like you don't have enough infrastructure, like all the second market of electric vehicles is not completely solved. We see like more electric vehicles on the road, but not with the same volume that we're accepting.
But beyond electric vehicles, I mean, I see that electric vehicles is a big part of the electrification revolution. Beyond electric vehicles, there's phones, there's laptops, electric bikes, scooters, watches. Is that happening faster? Are you able to make an impact there or make any inroads?
Yeah, so the pain in that market is not as big as in other applications. Technologies today can provide good enough like batteries for mobile phones, for watches, for others. That mostly in like all the air taxi, drones, robots. Today, one of the biggest challenge of robots is not the brain. They all have artificial intelligence that can operate almost like a human, but you need to wire them or they cannot like last more than 20 minutes.
The robotics, the robot arms in factories, but now you have the humanoid robots, Optimus and
I mean, the
all.
biggest challenge is the energy.
The energy.
Battery.
So that sounds like a good market.
Yeah, but it's not
Very
as
near
big,
the auto.
not mature yet, but definitely there are other markets. But, you know, as a startup, you need to be focused because if you are going to other markets, you have different sales cycles, different like end user. So everything is different and you need to have people in your company that will be able to operate in that environment.
To sum up, innovation in energy, innovation in battery technology. It seems like once you've solved the scientific and engineering part, which is very hard, you now have to really solve the scale and the business and the industrial side. And that's your big challenge. So what's your plan really to, is that through your investor? Is that through partnerships? What's kind of the overall strategy?
We want to continue to be a technology company to generate like a next generation of product. And it's not a static technology. It's very dynamic. Always we're thinking about the next generations and how we are going to be relevant with the technologies in the future to be agile, to answer the industry changes and trends. We are not changing or disrupting the whole market in terms we are not replacing infrastructure. We're not replacing the basic concept of a battery. It's the same battery, same infrastructure, same players in the supply chain. But the philosophy is to make small change, but a huge impact, especially in this very conservative and traditional industry. If you're going to make a big impact, infrastructure, etc., no one wants to volunteer to adapt this type of change. No one wants to actually push for that change. That market is very conservative. Think about it. You are a battery company. You need to build millions of batteries, for instance, for electric vehicles, and you don't want to have any explosion. It's like a fatal accident, like a recall, and can destroy companies. And if you all need to decide about what technologies to use, you want a zero interaction. You don't want a change. This is the way you design as an engineer, as a scientist, to have minimum change. So we are trying to understand that philosophy, that brain of the engineers in the production line, and to tell him like it's a second supplier. You can always go back. You can always see that it's fit into your existing technologies. It's a format agnostic. Doesn't matter which type of battery formats. Doesn't matter each type of process that you are using. We are going to be applicable And our philosophy is to build a technology, a product that will be exactly suitable for the battery technology in the market.
Yeah. I'll put in the show notes a link to Addionics blog, which I actually find, accessible. It's really great. I mean, you do talk about, energy innovations also in defense, electric vehicles, and with some more technical stuff, which is great. Did I miss anything? Is there anything you feel like we've missed, we haven't touched, or you think we've told the whole story?
Yeah, I think the fact that we are chemistry agnostic, process agnostic, there are different types of process, wet process, dry process, many paths and many trends, different chemistries, silicon and solid state. In the beginning, it was very difficult to convince companies that we're a platform. We are not trying to build like specific battery. We're not a battery company. It's a platform. We bet on the battery race. This is the only thing that you need to believe. If the battery race is going to continue and we are not betting on a specific course, that's the message, like the battery race.
That was the framing that I was looking for at the beginning, is there is a battery race, right? There's a battery race in electric vehicles and even in combustion vehicles. There's a battery race in planes. There's a battery race in all our devices. It's to get more out of the battery, more power, more energy,
Sure.
cheaper, less heat. And that battery race is worth a huge amount of value to all the brands and the big companies. And Addionics is doing research and production into not the layer outside and the management of the battery, but the actual chemistry of the battery and the actual physics of the battery. And how much we'll end off with this. How much more is there to discover in that race from a scientific engineering?
It's not a secret, but batteries are, as I mentioned, around for many years. So it's not a new concept. Thanks to Tesla, we see more and more innovation and more young talent join into that space. It wasn't sexy like 20 years ago. There is no any success stories or no, I would say, example. It was considered like boring industry. And today we see more and more talents and innovation around that. I still believe like there are many technologies that are beyond lithium-ion battery, but I still believe there are like lithium-ion batteries are here to stay for another decade for sure, and going to be the major player in that ecosystem. So if you want to build in the near term, you need to focus on the lithium-ion technologies. We understand that from the chemistry, you already squeeze everything on the cell level, the electrode level. So that was a room to take the other components that overlook, the inactive component, separator, binder, electrolyte, and current collector. And the current collector, among all the inactive components, was like the most overlooked one. So we took like the kid in the class that no one wants to play with, no one wants to dance with. Even the teacher said that there is no any potential for this kid. And we actually prove it wrong. That's what we're doing, taking that kid, and now this kid is super popular.
Were you that kid? No, you don't have to answer that. Okay, listen, I mean, I got it. I'm pretty sure a lot of my audience will get it. This has been fantastic. I really got the whole battery race and the science and the chemistry and why this matters and the business. I'm going to just say thank you. Finally managed to get you on the show, Moshiel Biton, CEO, co-founder Addionics. Thanks again.
Thank you very much for having me. It was a great pleasure.
Amazing. Great conversation.